triangle above, construct the locus of points equidistant from A and B. What will this be? Between two points, what will it be? A line, a perpendicular bisector, a perpendicular bisector. So make the construction of the perpendicular bisector. You can take any length, yes. It must just be more than half. More than half. The next one says the locus of points, which are, this construction is the worst one. This is where the mistake comes in. Look at this one. Equidistant from AB and AC. So what does that mean? Of AB and AC means it's the angle bisector. When it repeats like that, AB and AC, it is the angle bisector. So you can choose any arc. The secret is just to use the same arc there. So from A, we draw an arc. Then you put it here, and you put it there, and there is your angle bisector. So the third construction is the locus of points 9 centimeters from C. What is it from a point? A circle. So 9 centimeters now from C. So we measure and we construct then 9 centimeters from C. You construct a circle. Don't need to draw the full circle, just that part which is inside the triangle. Your line is too short. Draw it longer. You're not going to get the mark for that one. Your lines must go through the whole triangle. Don't draw it too short. The last one is a circle from from C. A 9 centimeter circle from C. Okay. Now, what we're going to focus now more on is those shadings. We've looked at the constructions. Now we're looking at the shadings. If you don't know, put up your hand, then I will come and help you. Okay. Now it says shade. Look now on your shape. Shade the region inside the triangle which are closer to A than to B. So what does that mean? It's up here. Then they say closer to AC than to AB, which means it's on that side, isn't it? And then the last one is more than 9 centimeters. So it must be more than 9 centimeters. So it's closer to A to B, then closer to AC than to AB between this line and more than. So this is where you're going to shade. That's then the part that you have to shade. Yeah, mine is small. Yours will be a little bit bigger. Okay, number 2, shade your region. Right, we're going to go over to number 2. It's another triangle. So there is the triangle. ABC. ABC. Usually it goes like this. The treasure, so there's a treasure hidden in a triangular field ABC shown in the scale. There's again a scale, 1 centimeter represents 10 meters. The treasure is nearer to AB than to AC, more than 10 meters from the line BC, but less than 50 meters from the point C. Okay, now let's first make the constructions and then we'll find the treasure. Equidistant from AB and AC. What is that? Angle bisector. AB and AC is an angle bisector. So you choose any arc and you draw the arc there. Then you use exactly that same length to make those arcs there. You put it there, and we draw the angle bisector. The angle bisector. The second one is 10 meters from BC. So what will that be? Yeah, a line 1 centimeter from BC. So there is the line, 1 centimeter from BC. 1 centimeter from BC. Make the construction, 1 centimeter from BC. You just use the same one. Okay, the next one says 50 meters from C. What is that? From a point, it is a circle. So from C, it's going to be a circle. So draw your circle. 5 centimeters from C, we draw a circle. Okay, where's the treasure? I'll read and you look on your papers. The treasure is nearer to AB than to AC. It is more than 10 meters from BC. and it is less than 50 from C. Where's the treasure? There's the treasure. There's the treasure. Now, closer to AB than to AC, more than that line, less than 5. It's just that part there. It's that part there. Okay, let's turn around. Number 3. PT and PU are tangents to an arc of a circle at T and U. Using straight edge and compasses only, construct the bisector of angle TPU. Okay, you do it now, and by drawing another line, find the center. It was not a full circle, 2 tangents from the same point, and the first construction that we made was the angle bisector. So that's now the one line that you have there. Now, to find the center of the circle, the other thing that we need to know is that the tangent to the radius is 90 degrees. So you have to construct here an angle with 90 degrees, or here, doesn't matter. Construct an angle of 90 degrees, and then where the 2 lines intersect, that's why you find the center O. So draw the tangent is drawn, form an angle of 90 degrees, and if you join that, you will find, so that's because they ask you to draw an extra line. So that's how we find that extra line then there. So construct an angle of 90 degrees. And then you will get that. Okay, and we're going to do the last one, number 4. So here is the sketch. Right, write the scale in the form 1 to n. Now, the actual length of the side AB is 100 meters, so it's 1 to 10. So the ratio is then 1 to 10. 1 to 10, n is 10. N is 10. The next one, in this part, use a straight edge and compasses only. So basically, you're going to use the compasses. That's what we're going to use. Leave your construction lines. We said that now. A tree in the field is equidistant from A and D. What does that mean? What is the construction if it's equidistant from A and D? Yes, a perpendicular bisector. So you choose an arc more than half, you put it on D, you make that arc, you put it on A, you make that arc, and then you draw the perpendicular bisector. So there is the perpendicular bisector, the construction there. The perpendicular bisector. And then they say the tree is also equidistant from BC and CD. What is that? If I say BC and CD, this is the angle bisector. Look at this. This is always where it goes wrong. So again, some of you are still struggling. I take an arc. Pesci, look here. I take an arc. I make the construction there. Then you put it on that line DC. You put it on BC. And this is then the angle bisector, the angle bisector that you construct, okay, the angle bisector. And where are you going to plant your tree? T. That is the point where we plant the tree, at T, where your line, your 2 lines intersect. Yeah, the line is a little bit more skewed, isn't it? So let's look at that first one there. This is then the class test on Loci. VWXYZ is a straight line. A triangle has sides of 3, 4, and 5 centimeters. It starts in position A and is rotated about its vertices as shown on the diagram. construct the diagram accurately. So you must do that first now. Construct the diagram accurately. So it's real dimensions. You have to draw it with real dimensions. That you made. This one was eventually 12 centimeters. There, and that one, and there. Okay, construct the diagram accurately. Some of you struggled a little bit, but we must make those constructions. Then they say, construct accurately the locus of the vertex P as it moves from P to P dash. Now, that was then with your compasses that you could do that one. Here is P now. This is the point P, and I have to go over now here to P dash. So what will be the locus of P? Now, if you take your compasses and you put it here, and it moves from that P, then it will go there, and then it goes up. So your locus will look something like this. That would be the locus of that point. Where's yours? Then they say, describe fully the rotation which maps B onto C. Now, if you struggle with these things, take your rubber and do the movement with your rubber. Mark on that one, so then you can see how it will change. So what is the movement from B to C? It is a rotation, isn't it? Okay, now this is transformations. We haven't done it now this year, but you already did it in grade 9. So it's a rotation. What is the center? What is the center? Okay, center X. And then we also have to say with how many degrees. This is the angle. This is the movement there. It moves from there to there. So you have to measure that angle there. It's not 180. I think it's 165 or something like that. Yeah, okay. So, and then with 143 degrees. So this is the movement. That is the angle that you have to measure there because it rotates like that. You can see how they combine these questions as well here. And then the last one says, describe fully the single transformation which maps A onto D. So the answer there is a translation. We call it a translation. A translation is like chess. It is a movement, and we do a translation with a vector, and the vector is now this movement here. So we have to add all the lengths of these sides. Now, this one was 3. This one will be 5. This one is 4, and this one is 3. So what is it in total? 15. So then is the translation with the column vector 15, 0. But that is something that we still have to... 0 because there is no movement up or down. We'll come back to this later on. Okay, question 2. I asked... This one is very similar to that donkey one that we had the other day. Okay. The diagram shows the scale 1 centimeter to 1 meter. It's the garden. It's tethered to a rope at P. So here's your P. There's P. And they say draw the locus of all the points in the garden that the goat can reach when the rope is tight. So that will be a 4 centimeter circle that you're going to draw there. A 4 centimeter circle there. And then the last one, calculate the area of the grass that the goat can eat. Now, what will be the area that the goat can eat? It will be this part. No, this is where he can eat. Sorry. This is where he can eat. So it's a quarter of a circle, radius 4 centimeters. So it's then a quarter of pi 4 squared. What did you get? 2 point? 12.6 square centimeters, no square meters. Yeah, otherwise the goat can't eat much. Right, now we come to the last question at the back. This was now a good exercise for you at home on your own. So number 3 now there. Okay. In this question, show clearly all your construction arcs. So we said you don't rub it out. Using straight edge and compasses only. The perpendicular bisector of BD. Now, this is B, and this is D. So the perpendicular bisector means now it's of this line here between them. So you will put your compasses on B and draw an arc. And you will put your compasses on D with that same length. And this is then where we draw the perpendicular bisector of BD. Remember, it's now that line. Oh, mine doesn't look very nice. It's a perpendicular bisector. Then they say the bisector of angle CDA. So this is the angle that we have to bisect. So if we bisect this angle now here, you make that arc. So I take again any arc length. And the secret is to keep that arc length, and then you put it here, make an arc, there, make an arc, and this is then the angle bisector, Shade the region inside the quadrilateral, which is nearer to D than to A. So this is now this line closer to D, and then nearer to DC than to AD. So where are we going to shade? Here. Isn't it? Yeah. This is where we're going to shade. Yeah. Yeah, you shouldn't cross this line here. Okay. So that is then the homework. That was the homework. So now we're going to make nets today. We're going to draw now nets of shapes. Nets. Now usually you can just summarize it in your book now first. So if we have a cube, then the basic net looks like this, where you have the 6 faces and those 2 wings. If it is a cuboid, then these 2 will be equal and those 2 will be equal. The big thing, you must summarize this, the big thing that we need to remember now is that these sides fold on top of each other. So they must be equal in length. All the sides that's going to fold are equal in length. You can have others also, but for the cube and the cuboid, this is basically, or this is the easiest one to do. So there's the cuboid. So we have a smaller one and a bigger one, smaller one, and again those wings. Those lines should be equal to fold on top of each other. That's what's very important there. Exercise 7.1, and we're doing then answering the questions starting at number 6. So there you've got the picture there, the line y is equal to 4. So this is what we have here. There is the line y is equal to 4. There's no gradient, and it meets the line 2x plus y is equal to 8 at the point A. Find the coordinates of A. So what will it be? Coordinates is solving simultaneously. This one is actually very easy because you can just say 2x plus 4. So I substitute the 4 in y's place is equal to 8. So the value of x is then 2. X is equal to 2. So what is the coordinates? Because they want coordinates, so you must give it as a coordinate. Read the question. So it will then be 2, 4. 2, 4, which is the coordinate there. Then the next one, the line 3x plus y is equal to 18 meets the x-axis at the point B. What is the coordinates of B? Now, it is 3x plus y is equal to 18. We know now that when you meet the x-axis, y is 0, isn't it? So then we can just say 3x is equal to 18, which makes x equal to 6. No, 6. So the coordinate is 6, 0, because you cut the x-axis. And then the next one, find the coordinates of the midpoints of M joining the line A and B. Now, we have the coordinates of A and the coordinates of B. So this is the two that you are working with now here. This one and this one. And now we have to find the midpoint. So it's just the midpoint formula. 6 plus 2 over 2. You can't say that this is difficult. 0 plus 4 over 2. It's just my formula. And the answer is then 4, 2. So the midpoint is 4, 2. And then they say find the equation with a line parallel to that line. So if it is parallel, now just remember this one 3x plus y is equal to 18 is now not in standard form. So it means you do not have a gradient at this stage here. Right? So what is the gradient of this one? So m is negative 3. So the equation will be y is equal to negative 3x plus c. And this line passes through the through M, through the midpoint. What was the coordinates of M again? So 2 is equal to negative 3 times 4 plus C. This is how you will calculate C, the value of C, 14. So the equation is y is equal to negative 3x plus 14. Don't forget to write. Right, the next one is question 7. A is the point 5, 10, B is the point 30, negative 2, and it is 2 points. The perpendicular bisector of the line has a gradient of 2/3. They give you the gradient. Find the equation of the perpendicular bisector. So I still want y is equal to mx plus c. They are so nice, they give you the gradient and they say it's 2/3 x. How do I find c? Which point should I substitute? The midpoint, because it's the perpendicular bisector, and at this stage I don't have the midpoint. So I first need to calculate that. This is the midpoint. You have to calculate the midpoint. 9,4. Okay, so now I can substitute it in here. So 4 is equal to 2/3 times y plus c. Negative 2. So the equation is y is equal to 2/3 x minus 2. Minus 2. Understand? Okay, so that's then the equation. That was what our father homework was, isn't it? So now we're going to start with, right, so the picture looks like this, and we have this one. Okay. So A is negative 3, 3. B is 3, 9. C, write your coordinates in so that you can see it, because the coordinates is now not where they should be. And this one is then D, negative 3, 3. No, 0, 3, negative 3. So write them in. That's what the word respectively also means, is each one is that point. So the first question now there is calculate AD. Now remember, this must be one of the 3 formulas. It must be one. You must just find out which one it's going to be. So if I say find the length of AD, then it means that I'm going to find this line. This is then the line AD. That's what you need to find. How do we do that? With a length formula. Okay, do that one on your paper. Do it with the length formula. We all do this question now together. You shouldn't wonder, must I add or subtract? What is your answer for the midpoint? Okay, so what do you say? Okay. Okay, and then they say, show that the line AB is parallel to DC. So let's go back to the sketch. AB must now be equal to, AB must be parallel to DC. When will they be parallel? If their gradients are the equal. So calculate the gradients now. So now we're talking about the gradient formulas. It's one of your three formulas. So this time it's the gradient formula. AB and DC, you have to calculate both of them. AB as well as DC. Finding those gradients. Finding the gradients. So this one's gradient is equal to this one. So I make the statement again, AB is parallel to DC. Make that statement. AB is parallel to DC. Hence give the geometrical name of the quadrilateral. Just look at the shape. Yes, you're right. It's a trapezium. It's a trapezium. I've got the two parallel lines now. That's what you've proven. So it's a trapezium. And then the last one, obtain the equation of DC. That is the diagonal that we need to calculate now. DC. So what do I want? If I must obtain the equation, what do I want? What is the equation of the line? So we said what we want is M and we want C. We already have the, no, yeah, we already have the gradient. So Y is equal to 1x plus C. Which one? D or C? D or C, because it passes through those 2 points. So you substitute one of them in there. D or C. What is D? Negative 3 is equal to 1 times 3 plus C. So what is C? Negative 6. So your equation is Y is equal to 1x minus 6. Minus 6. Okay, this is what you're going to get. This is exactly what you're going to get, this question, like this one. Okay, so would you get 12 marks here? Okay, so now I want you to continue with that revision exercise. Let's continue then with the revision exercise, number 1, 2, and 3. We are busy with a final revision exercise then, ready for, and I think we should start with number 2, marking there number 2. Right, so the first one says, using a scale of 1 centimeter to represent one unit on each axis, draw the following lines. So I said you can do this one just in your books. We'll do the second one on graph. Or there is actually graph paper there. Okay, so the equations that we are drawing is y is equal to 2, x plus y is equal to 6, and y is equal to 2x. And by now, this should be very easy for you to draw these lines now there. So the first one, y is equal to 2. So this is then here. And that is the line that we are drawing there. So it's just the lines. This one changed to standard form. So y is equal to negative x plus 6. So we start here at 6. We've practiced this method now a lot of times. The gradient is 1 over 1. Or you also know that you'll have to cut here at 6 also if it is a 1. And there's then my straight line for that one. Be careful, sharp pencils to draw that one. What about this one? There is no C, which means that line starts here at 0. What is the gradient? Delta y over delta x, 2 over 1. 2 over 1. Okay, you're right, it's delta y over delta x, so it's 2 over 1, like this. There's the 2 and there's the 1, so this is the line. Sorry, yeah. Okay, and then let's just get the inequalities. So y is more than equal than 2, and the last one less than equal than 2x. So first we've drawn the lines. Now we need to shade unwanted regions. This is the wanted region, so I'm shading here. If we test this one, is 0 more than equal than 6? No, that's false, isn't it? So that means for this line, 0, 0 is in the unwanted region. So I'm going to shade here. And then the last one, now it doesn't help to take the point 0, 0, so we need to take another point here. Oh, 6 is less than equal than 12. Okay, so for this line, 6, 6. Okay, I can't see on mine, on which side is now the wanted one. Okay, so that is true. So this is the wanted region, meaning we're going to shade here. So this is the region that you get out there on that one. Okay, the next question is question 3. The diagram shows KLMN, you have the coordinates there. We have 2 equations, and in the first place, you have to calculate now the coordinates of L. How do we get coordinates? We solve we solve simultaneously. So it's 3y is equal to 4x minus 6, and it is 4y is equal to 3x minus 1, solving simultaneously. This is not an easy one. We'll have to make a change here somewhere. I'll multiply this one by 4 and this one by -3. There are other possibilities as well. So this is then 12y is equal to 16x minus 24. And here, negative 12y is equal to negative 9x plus 3. I hope you can see how many times we use algebra. All the time, it's algebra. So this one eliminates. And here we have 7x plus 21. No, minus 21. Minus 21, so 7x is equal to 21, which makes x equal to 3. X is equal to 3. And the y value, you can go back in any of the others. What do you have? 3, 2. So this is the coordinates of L, the point L. Then this is also a question out of an old exam paper. Calculate the length of the side of the rhombus. So what do we know about a rhombus? All 4 sides are equal. So you could have used any one. I'm going to use now K and L. So the coordinates of K is -1, -1. And the coordinates of L is 3, 2. I like to write it like this so that I know which coordinates I'm working with. Otherwise, you get confused here. So I want the length. Which formula is it then? Pythagoras. So it will be, it doesn't matter which one is x1 and x2. You can choose any one. It doesn't matter. So -1 minus 3 squared. And we've seen we should put extra brackets there if you keep on getting wrong answers. Plus, and on this side, it is then -1 minus 2 squared. So what is your answer for this one? Exactly, 5. Yeah, you're right. And then the next question says, write down the gradient of the line KN. The gradient of the line KN. Now, what do we know about Kn? No, I would say Kn is parallel to Lm, isn't it? Lm is parallel to Lm. So I'm going to start off there with Lm, which is 3y, is equal to 4x minus 6. And I need to always, y is equal to mx plus c. We always have to go for that, minus 2. So what is the gradient now going to be? 4/3. So the m of kn is 4/3, the gradient. And then they say find the equation of kn. So now it will be y is equal to 4/3 x plus c. How do we get c? We need to substitute coordinates. So what are you going to put in now? What do we have? K. We don't have n, we only have k. So we're going to put k in there. So it's then -1 is equal to 4/3 -1 plus c. So what is the value of c? So -1 plus 1 1/3 is 1/3. 1/3. And then the last one is calculate the coordinates of the midpoint of km. So this is now D1, the midpoint of km. So obviously it's going to be the formula for the midpoint of km. So I have the k, which is -1, -1, and I have m, which is positive 6, 6, isn't it? So what would be the midpoint here? -1 plus 6 over 2, and then -1 plus 6 over 2, which is what? Yeah, or 2.5. 5 over 2, both of them. Like that. Or you can say 2.5, 2.5 doesn't matter. And then the vertex n. Calculate the coordinates of n. So how will we get n? How do we get coordinates? SS, solving simultaneously. So which two sides do we have to equate now for D2 now? We want n, so we have to work with kn and nm. Okay, now we know that opposite sides are parallel here, so you have to use those facts there. Did we calculate the KL just now? Which one's gradient do we have? Now we have LM, KN. So we already have KN. So we need to find NM. Okay? Okay, just give me the equation of KN. Sorry, KN. Yeah, what is it? A third x? Yeah, so y is equal to 4 over 3x plus 1/3. And then the next one that we need to find now is NM, but we don't have this one. Okay, and this one is then parallel to KL. So that one's gradient is 3/4, isn't it? So it is y is equal to 3/4 x plus c. And then which one's coordinates do you have here? M, which is 6, 6, yes. So 6 is equal to 3/4 6 plus c. And what is the value of c? Is it right? So y is equal to 3/4 x plus 3 over 2. And this one. I'm not going to work with fractions here. Get them to whole numbers. You won't be able to work with those fractions. You're just going to make mistakes. So if we get rid of the fractions here, I can say that 3y is equal to 4x plus 1. And so this is the one equation that we are working with. And now I take this one and I change it to get rid of the fractions in the first place. So it will be 4y is equal to 3x plus 3. LCM times 4 times 4 times 4. This one is not right. It will be plus 6. Okay, and then solving simultaneously. So this one is also not solving easily simultaneously. We'll have changed. That was your two coordinates now there of n. Solving simultaneously. Come on, I can't do everything. Times 4 times -3. So it is 12y is equal to 16x plus 4. And this one will be negative 12y, which is equal to negative 9x minus 18. So if we solve the two now simultaneously, this one is 0. And then this one is 19x plus, is it true? No, 7x. 7x plus 4 minus 14. So, no, minus. So here it's 14 and x is then equal to 2. So what is the value of y? 3. So the coordinates of n is eventually 2, 3. 2, 3. There's the coordinates then there.
I like rhinos. I like them very much. Future here in this area is depending on the tourism. The future generation, they can see and they can benefit from their own resources. Animals like rhinos, elephants, the big five, you benefit from them and it must be respected. You are not feeding the rhinos, you are not giving them order, so it's a free business. I think 2 of my sons, which was little bit 5 years old, they were young guys. So they asked me questions. Why are we here? Why are we sleeping here? I told them this is our resources and this is our future.
My first memory of going with my dad is that I learned new things. As I grow up as a man, I see an opportunity in it. So I decided to look for a job pertaining to tourism. So that's when I was employed at Palamba. So I decided to go for tour guide studies. Because I grew up with the tourism industry, the wildlife, the rhinos and everything, to bring that experience to the tourists. You can see the hyena. The biggest changes, I was employed, getting paid, and also I can now support my family.
It's a cultural thing. It's coming a long way. Even if you go to area like Treverfontein, area was a lot of paintings. You will see rhino engravings on the rocks. That is an indication that the interaction between human, especially the local communities and wildlife, is dating back. That intimacy relationship is coming for a long time.
We are right here now at Palambach, and Palambach is one of the big lodges in the heart of the desert. And as you can see there is Jumbo standing behind me, which shows it's really a tourist area. We do have elephants, lions, but as you can see, the desert is the heart of the rhinos. This is the main breeding area of the rhinos, is what we found here in this desert.
It's the largest free-roaming population of black rhinos that you find outside national parks in the world. It's a population that communities in the Northwest have taken responsibility themselves in managing this population with the structures that government has put in place, more specifically the establishment of conservancies.
These people, before independence, they took it upon themselves and decided that wildlife is our heritage, and through history we've been living with wildlife. And having wildlife in your area is like having a garden.
Because of all these animals, we've got the communities that benefit from all this wildlife, and it's like a triangle that fits into each other. And the communities looked after the wildlife doing their own thing, and the communities benefit.
So already there were this intergenerational relationship between mankind and wildlife, and that bond is what our people actually wanted to see it continuing.
Very few countries have the wildlife that Namibia has. What is also important is the policies that Namibia has put in place, which also involves communities to be engaged in the management of the wildlife species and also to benefit from the wildlife resources.
Turn conservation into a rural economy, turn conservation into endless opportunities that would actually cater for those young people that have nothing else to do.
If it was not for rhino economy and tourism in this area, it was really difficult for young people to get or find a job.
We are conservation engineers. We make conservation work in an unfenced area, and through that, we want to turn the wildlife into the rural economy that will benefit the rural communities.
So we can see now wildlife is doing very well, the lodges are doing well, and the community is also benefiting. So it takes all three together.
Devastating hit over coronavirus fears. Airline industry is facing its biggest threat to travel since 9/11.
Since March, when COVID-19 hit Namibia, things actually become very difficult. In the first place, all the lodges closed down because of COVID-19. With us, Save the Rhino Trust, we had some donors cutting on their funding. And then we had, in the same time, a poaching case of 2 rhinos that was poaching. We had less boots on the ground, and poachers could actually see. Now it's our chance to go in and do something. So COVID-19 was tough on all of us. Ginger Morning, who is one of our trustees, actually came up with the idea of, why don't we ask you to go to buy some gold for us and make gold bars, and then we sell them for rhino conservation.
I was fortunate enough to have a chance to have lunch with Clive Johnson, the CEO of B2Gold in Vancouver, Canada. And I looked at Clive and I said, we've got rhinos, you've got gold, let's do something. Let's create a coin or a medallion or a bar using your resource to create a sustainable source of funding for rhino conservation for the future.
That was it. The gold was bought, the bars was made, and I think it was 31st of January that we launched the bars in Windhoek. And suddenly one morning I had an email from my office, from my finance person, saying, these people don't have salaries. So I said, oh, what now? So I picked up my phone and I phoned Magdo I said, Mark, I've got this problem. He said, but we've got the fund already ready for you. You just have to apply, put the proposal in.
1,000 ounces of gold can make an enormous difference to the livelihoods of the communities that live up there. We are, in essence, providing income and providing a livelihood to the communities. In the absence of tourism, especially now with COVID-19, even prior to that, when we had such a bad drought, the communities became even more dependent on the natural economy.
The idea is to make this a fund that will last for the next 25, 30 years, or even longer. And a portion of that will be distributed immediately as needed. And in this case, the COVID-19 crisis necessitated us to distribute funds to pay salaries to help people in the field.
The proceeds of the sales from the gold bars will be going towards responsible NGOs. And we've identified Save the Rhino Trust as the key NGO. And IRDNC, one of the first organizations that was in the Northwest, integrated rural development and nature conservation, so that ultimately the funds go to the communities and various aspects of their war on poaching.
To be able to support those hardworking men and women that are always in the front line between the poachers and the rhinos.
If it was not for B2 Gold and the golden bars, I think by now we should have been in big trouble.
By extracting the gold, you reinvest it in other renewable resources.
The gold that's coming out from the ground is actually protecting the wildlife that's working on the ground, which is a very good symbol for the others.
I wish this was my bar. This is the 500 gram gold bar. So you'll see on this side you've got the Etindeka Mountains and you've got the mother rhino with her calf. And then on the reverse side we've got the serial number, you've got the Rand Refinery stamp, which is very important. Anywhere in the world people will recognize this stamp and they will know that this bar contains 99.99% gold.
It is gorgeous.
We wanted to make a biggest contribution. And at Ballowwood we see that as a way of giving back to the community.
Okay, so there you'll see the 500 gram bar.
Very special.
Feel the weight. It's incredible.
This opportunity which presented itself is absolutely a once-in-a-lifetime opportunity.
We're privileged to have this.
This is just absolutely gorgeous, and I think this showcase really what the project is all about.
It's from 24 karat Namibian gold.
I'm looking at these rhinos is put there like Miss World photogenic, I would say.
There are only 1,000 of these gold bars, rhino gold bars, in circulation.
As far as I'm aware, it's the largest single donation of any corporate to the conservation of biodiversity anywhere in Africa.
Therefore, we so much appreciate and would want to continue as a government to work with B2 Gold.
And the fact that it's happening here in Namibia is something that we can all be extremely proud about and very grateful to B2 Gold.
Thanks to having this literal pot of gold through the funding for the Rhino Gold Bar, we're able to step in now and make sure that those trackers are supported, and so are their families and their communities.
We make sure that people sustain their jobs going forward, and who doesn't want gold?
And the B2 Gold Rhino Gold Bar has come in at a really critical time now, particularly with tourism being closed off and those forms of revenue not coming in.
To say we have the biggest rhino population or black rhino population in the world, let it be for the rest of our lives. And it's that heritage that we have, it's our resource that we can all look after and protect.
It's our heritage. And it's also good that other people like B2 Gold are also seeing it that way.
It's actually a very nice link between the investor that buys this gold bar, the rhino tracker in the northwest of Namibia, and the black rhinos. It's an intergenerational thing. The rhino trackers teach their children how to track rhinos, their children get taught, and so it flows down.
This is something that I want my children to have, and that we leave a little bit of a B2 Gold legacy. And if I can be part of that as part of my family, I'd be very proud.
It can also become an inheritance for the generations of my own clan, my children, my grandchildren.
If we can bring that passion over to future generations and to hand that over to my children, and I hope that that same passion for conservation gets migrated over to my kids.
And what we've done together is create a sustainable source of funding that should outlive all of us.
You know, I think as far as B2Gold is concerned, we couldn't have chosen a better target in which to put our efforts as far as the environmental and conservation pillar is concerned. And I want to stress there that the money that's going towards environment and conservation is actually going towards the people.
Rhino is for all of us, whether you are in Canada, whether you are in Vancouver, whether you are in the US. If you really want to see conservation at play with rural communities, I therefore humbly request each and everyone to join us on our Rhino tour and have a wonderful experience. This is what keeps rhinos on this planet.
I've done rhino trekking experience. It was just amazing walking in that landscape of the Kunene. And as we followed them, we could now find rhinos with the calf. We got the closest distance we could.
It's a warning sign.
And it was just amazing and lovely. It's something to experience that Namibia can offer. It's something that you have to do in your life.
Was in and out of prison, dealing and doing drugs. Then a drug deal went wrong. Joseph was robbed, handcuffed, and scared straight out of the business. For 6 months, he roamed the streets as a homeless addict. Then one night, in a baseball dugout, Joseph met a stranger who totally changed his life.
I stand in awe of the power of the God who's our creator. And Terry and I sit here on this program, and the Lord speaks to us, and it's the word of knowledge. It's one of the manifestations of the Holy Spirit.
Something not always godly.
Not always, that's right. That's right. Well, there's a lot of negative voices out there, as we know.
Yes, there are.
And
so how do you know when it's God saying, Perry, I want to speak this to you right now?
And sometimes you don't know. And I think you pray over it, and you think about it, and sometimes you just, a lot of times I'll just envision, as you and I are talking here today, I may envision that I'm here talking with God, and how am I supposed to address this issue?
Okay? Realize Jesus is the same yesterday, today, and forever. He is the same for you right now. So let's pray. Let's call on his name and let him do the rest for you. Let's pray.